Hello everyone, my name is Coco and I'll be representing my team in this video presentation titled FlexiSense, Novel, Low Cost, Flexible, Carbon Dioxide Gas Detector from Shape-Induced Polymerization of Nanopolyaniline on Graphene, and I hope you'll enjoy it.
Before we begin, I would like to introduce my team members from UCSI University as shown on screen now. We would like to convey our special thanks to UITM for organizing this competition. CO2 gas is harmful for the environment and human health, hence there is a need to detect the amount of CO2 gas in the atmosphere. Conventional gas detector machines are bulky, expensive, and unsuitable for on-site detection of CO2. Thus, a wearable sensor named FlexiSense was designed by casting graphene polyaniline nanocomposite onto low-cost, flexible filter paper substrate. To date, there is no study on how different shapes and dimensionalities of pani in Figure 1 alter the electrical properties of the FlexiSense to improve CO2 detection efficiency via the mechanism in Figure 2. This is in fact the problem statement and novelty of this project. This project aims to synthesize FlexiSense via direct growth of pani of different shapes and dimensionalities on graphene and casting the nanocomposite onto filter paper, probe morphological changes and interfacial interactions in the graphene pani system, and validate FlexiSense responsiveness to CO2. As depicted by the flowchart in Figure 3, the research begins with the synthesis of nanomaterials before analyzing them via different characterization tools and lastly testing the FlexiSense responsiveness to CO2 gas. This project has immense impact in achieving all three pillars of sustainability as well as progressing the application of nanotechnology in society. The synthesis of graphene and 0D, 1D, and 2D pani from in situ chemical oxidative polymerization of aniline on graphene are depicted in Figures 4 and 5 respectively. The FlexiSense was fabricated by casting graphene pani nanocomposites onto filter paper. The conductance of the sensors was validated by resistance measurements, whereas the interfacial interactions between graphene and pani were verified via FTIR and XRD analyses. A series of tests was conducted which validated that the FlexiSense is highly responsive to CO2 gas. It is noteworthy that the present innovation is in TRL4 stage. It was found that the electrical properties of the FlexiSense varied according to the different shapes and dimensionalities of pani, which ties back to the novelty of the project. This is attributed to the variation in the extent of stacking and orientation and the decrease in the difference of aspect ratio between pani and graphene substrate as shown in Table 1. As seen in Table 2, graphene pani 0D has the highest electrical conductance and appears to be the best candidate for CO2 detection. This is due to the large difference in aspect ratio between pani 0D and graphene nanosheet, the greatest pi-pi stacking interactions and compound formation between the two entities, and hydrogen bonding. On top of that, sulfuric acid enhances the protonation of pani, forming para-coupled and conductive pani emeraldine salt. Moving on, in addition to CO2 responsiveness, the innovative product FlexiSense, flexible CO2 sensor, boasts superior advantages. It is flexible, light to carry and wear, low cost, small in size, portable, and suitable for on-site detection of CO2 gas. From the total cost of fabricating 35 pieces of FlexiSense, it can be calculated that one piece of FlexiSense only costs 28 cents in Malaysian ringgit. This proves the cost effectiveness of the flexible sensor. In summary, the innovative FlexiSense product offers positive impacts to the society, economy and industry, environment and the nation. The innovation is novel in terms of the strategy used to alter the sensor's properties by changing the morphology of pani. Thus, the results obtained in this study provided fresh insights into how the shape and dimensionality of pani affects its interfacial interactions with graphene and the electrical conductance of the nanocomposite as a whole. Moreover, this study serves as an essential step towards manufacturing and commercializing the FlexiSense at an industrial scale. Before we conclude, we would like to acknowledge our research grant and our past achievement. We hope this presentation has been informative and valuable to you all. Thank you for your time and attention.